We are going to find the distance between a point and a line. Here's our line, here's our point. There are several steps to this, so in order to do it, we are going to use a rhyming device, and we're going to sing it like this. We're going to get 3 pieces of information, 2 equations of lines, 1 point of intersection, plug it back in. That's 3 pieces of information, 2 equations of lines, 1 point of intersection, plug it back in. Alright, now let me explain a little bit. Our 3 pieces of information. In order to find distance on the coordinate plane, we need 2 points. And then we're going to apply the distance formula to find our distance. Okay, now let's talk about where these 2 points come from. We've got 1 point, and the other one is going to be formed by our lines. So let's go ahead and let's graph our point and our line. So when we graph -3, -2, we put a dot. So here's -3, -2, and our line is represented by this equation, which looks a lot like y equals mx plus b, where m is our slope and b is our y-intercept. So slope is -1/2. Our y-intercept is 2. So in order to graph it, we want to go to +2 and put a dot, and then apply the slope. So we're going to go down 1 over 2, and then we can just connect the dots to make our line. Alright, so here is the line that is this equation. So this is y equals -1/2 x plus 2. That's the name of this line. And I want to know what the distance is between this point and this line. So the next thing I'm going to do is I'm going to take a 90-degree angle and I'm going to draw my representative distance. The shortest distance between a point and a line is to go straight to the line, and that is a perpendicular line segment. So this orange line represents the distance between the point and the line. And this point is the point of intersection. So if I can find these 2 points, then I can use my distance formula on this line to figure out what the distance is. I've got 1 point, and my 1 point that I have is -3, -2. This is the point that I want. And I can only find that by finding the equations of 2 lines and then finding their intersection, which brings us back to this. I'm going to have 3 pieces of information. I need 2 equations of lines, 1 point of intersection, plug it back in. Okay, so my 2 equations of lines, they give me 1. We've already graphed it. So y equals -1/2 x plus 2. Our second equation of line, I would love to use y equals mx plus b. I can figure out what my slope is. The slope of this line is -1/2. My perpendicular slope is going to be the negative inverse of this. So if I take the negative of a negative, that makes it positive. If I invert 1/2 or take the inverse of it, that's 2 over 1. We're just simply going to flip it. So my perpendicular slope is going to be 2. But I don't know what my y-intercept b is, because I don't have that. I can guess, but sometimes you can't even guess. Alright, so I can't use that. But what I do know is that I know the slope, and I know one of the points on this line. It's this one, -3, -2. So when you know the slope and a point, you use the point-slope formula, which is y minus y sub 1 equals m times x minus x sub 1. We get that from our slope formula. Alright, so we know our slope. It's going to be 2. So I'm going to put 2 in here in place of m. And now I need the rest of it. And this is our point, -3, -2. So I'm going to label it x1, y1, and plug it in. So I'll have y minus -2 is equal to 2 times x minus -3. Okay, now all that's left to do is solve. If I get both of these in y equals mx plus b format, then I can put it in my calculator and have the calculator figure this for me. Alright, so 2 negatives make a positive. Y plus 2 is equal to, let's put this positive. Now I'm going to distribute the 2. So 2 times x is 2x plus 2 times 3 is 6 I need to get the 2 to the other side, so let's subtract 2 from both sides. Y is equal to 2x plus 4. All right, now let's look, make sure. So our slope is 2, up 2 over 1, and then our y-intercept is going to be 4. We actually could have guessed this one, but some of them you can't guess. And these are my 2 equations. I have this one, and I have this one. And these are the ones that I put in on my calculator to calculate my point of intersection. Okay, to save time, I've actually already done that. And you'll see that I've got my negative 1/2 x plus 2 and 2x plus 4. So we're going to calculate the intersection. So we press second calc, 5 for the intersection, and then since there's no curves, I'm working with linear equations. I just press enter, 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 and my intersection is at negative 0.8 and 2.4. So my 1 point of intersection is negative 0.8 and 2.4. Okay, so this is the one that goes back here. So negative 0.8 and 2.4. And these are the 2 points that I use in my distance formula. So real quickly, x1, y1, x2, y2. Let's remember our distance formula. The distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we're just going to plug it back in. Open parentheses, x sub 2 is negative 0.8 minus x sub 1 is negative 3 squared plus, open parentheses, y sub 2 is 2.4 minus y sub 1, which is negative 2. Okay, so minus a negative 2 squared. Alright, now this looks complicated and so we don't want to make any errors, so let's put it in on our calculator. Alright, when you're doing the distance formula on the calculator, you start with second and a square root, and then you've got to open the parentheses for this one. So immediately we open the parentheses, even if it provides you with one, open another one. And we're going to put in negative 0.8 minus a negative 3, well, which is plus. Let's just do plus. Plus 3, close parentheses, squared, plus, open parentheses, 2.4 plus 2. Close parentheses, squared. Now let's make sure that this looks right. So it's negative 0.8 plus 3 squared plus 2.4 plus 2 squared. And if I press enter, I get a distance of 4.92. So my distance is equal to 4.92. And anytime you get an answer, go back and check to make sure it looks right. So let's see, if a distance of 4 is 1, 2, 3, 4, this, and these all look square, then I can hold this up and think that 4.9 is a pretty good guess, because it's not just 4, it's almost another one. So 4.9 it is. So here's my distance.